use the equation of the parabola that we derived yesterday from the focus and the directrix, along with the equation y equals negative 1/2 x plus 8 to find their solution, where the two graphs will intersect. So first, since I have the parabola already in my equation, we'll solve this graphically. Already in my calculator, we'll solve this graphically. There's the parabola, there's the line. I hit graph. They intersect in two spots. I can find the intersections by going second trace, number 5, and then my cursor is already up near the intersection in the second quadrant, so I'm just going to hit enter 3 times. There's our first intersection point, negative 3.9, comma 10. And then my other intersection point, I'll do the same thing. Second trace, number 5. Move my cursor over to be closer to the intersection in the first quadrant and hit enter 3 times. And there's our other intersection, 5.9, comma 5.1. Now we'll return back to the equations and solve this system algebraically. Since both equations are equal to y, equal to the same amount, they're actually going to be equal to each other. And then I have one equation with one variable, the x variable, that I want to solve for x. So I'm going to get rid of this whole dividing by 8 mess on the left by the opposite operation, multiplying by 8 on the left, and on the right, we'll turn the right into negative 4x plus 64 equals x squared minus 6x plus 41. Since this is a quadratic equation, I'm going to make it equal to 0 by adding 4x and subtracting 64. Which will leave me x squared minus 2x minus 23 equals 0. And now at this point, it does not appear like this can be factored. So we'll either do completing the square quadratic formula. I'm going to do it by completing the square. So I'm going to move the 23 back over to the other side. And my magic number to complete the square is going to be half of b, which is 2. Half of 2 is 1, and 1 squared is 1. So I'm going to add 1 to both sides of my equation. X squared minus 2x plus 1 factors into x minus 1, x minus 1. And 23 plus 1 is, of course, 24. Solving for x, take the square root of both sides. So we're going to get plus or minus square root of 24, which is really square root of 4, square root of 6. Which is really 2 square root of 6. And then last thing to do, add the 1 over to the other side. 1 plus or minus 2 radical 6. And if you plug the 1 plus 2 radical 6 into your calculator, and 1 minus 2 radical 6 into your calculator, you get these two values, 5.9 and negative 3.9, which were the two x values of our intersection points. And then to find the y values, we'll plug this 1 plus minus 2 radical 6 into one of our original equations. I think the line will be easier. So negative 1/2 plus, or negative 1/2 times 1 plus or minus 2 radical 6. And when you plug those into your calculator, you get 5.1 and 10. Which were the y values of the intersection points on our graph. Now we'll move on to 3x3 systems of equations, where you've got 3 equations and 3 variables. Now the key to this is right at the beginning, find a variable that you can make have the same coefficient in all 3 equations. So in this case, we could turn x's all into 2's, since 2 of the equations have 2 x's in them. Or the other easy thing we could do is change the z's into 3's, since 2 of the equations have 3 z's in them. I'm going to go the z route. I'm going to multiply the second equation by 3 to change all into 3 z's. So this new equation will become negative 6x plus 3y minus 3z equals 27. Bring this New equation back here to the middle. Now to eliminate the z's from the first two equations, I can add the two equations together, which will make negative 4x plus 2y equals 20. And I think I can do the same thing with the second and third equations. If I add them together, the z's will be eliminated. That will give me negative 5x minus y equals 25. So now I'm down to two equations with two variables. Now we need to get one of the variables to be the same. We could either change the x's into 20s or the y's into 2's. Changing y's into 2's is going to be much easier because we'll only have to multiply one time. So that will change us into negative 10x minus 2y equals 50. This equation is gone. And now to eliminate the y from the red equation and the green equation, looks like I can add these together. Negative 4x plus negative 10x is negative 14x. 2y plus negative 2y is nothing. And 20 plus 50 is 70. Solving for x, dividing by negative 14. 70 divided by negative 14 is negative 5. And then I can plug that into, I'll plug it into the red equation. Negative 4 times negative 5 is 20. 20 plus what would make 20? Well, 0. So y has to be 0. And then we'll have to plug x and y into one of the original equations to solve for z. I'll do the first equation. So 2 times negative 5 is negative 10. Minus 0 is just going to be negative 10. Plus 3 times what makes negative 7. So when I add 10 to negative 7, I will get 3. And 3 times what is 3? 3 times 1 is 3. And those negative 5, 0, and 1 are our three answers.